Alright, so we got in front of us a graphing quiz. I hope y'all figure this out. I hope you do. First off is a mother function. All lines look like y equals x. And you're supposed to give me 3 key points, and I'll modify this to say it. But she contains 0, 0, 1, 1, and negative 1, negative 1. I got to see those 3 key points. I do. And she continues forever left and forever right, so you could do like negative infinity or to infinity. Or you could do all values of x such that x is an element of the real. Her range, she falls forever, she rises forever. Also negative infinity to infinity. Or all values of y such that y is an element of the real. Second mom function we actually looked at was absolute value of x. She also has 3 key points. She contains 1, 1, 0, 0, and negative 1, 1, and she is a v. Her domain's a little bit different. Her domain is the same, negative infinity, positive infinity, because she runs left and right forever. Or if you like set builder, all values of x such that x is an element of the real. Her range, her low y value is 0, her high y value is infinity. Or all values of y such that y is greater than or equal to a 0. Now we have x squared, something we also talked about in all the prereqs. Also has 3 key points. She contains 0, 0, 1, 1, negative 1, positive 1. And she is a u, the parabola. Her domain is the same as absolute value. Runs left forever, runs right forever, negative infinity to infinity. Or if you like your set builder notation, all values of x such that x is an element of the real. It's like repetition here, isn't it? The range is the same as the v, from 0 to infinity. Or all values of y such that y is greater than or equal to a 0. All right, next up is x equals a constant, which is your vertical line. There's one key point labeled C0. I'm just going to put it somewhere. Doesn't matter where it is, but it is labeled C0. Its domain is simply C. It is the interval that contains C, or all values of x such that x equals a constant. Its range, falls forever, rises forever, is negative infinity to infinity, or all values of y such that y is an element of the real. And we have y equals c, which is the horizontal line. It has one point called 0c. And it doesn't matter where you put it, but you're going to draw a horizontal line, and your y-intercept is 0c. Now its domain, since it's horizontal, it runs left forever, negative infinity to infinity, or all values of x such that x is an element of the real. Its range is simply that one singular element, the constant. Or if you like your set builder notation, all values of y such that y equals c. All right, here we have an inequality. It's x less than 4. Now, because there's no equality, there's no solid lines, there's no solid holes. It's just that dotted or dashed line, however your teachers have said that in the past, and less is left. So I shade left. It really doesn't make sense to talk about domain and range on that particular graph. So it's getting marked through. Here we have a straight up mx plus b. We have a y-intercept at -2. We have a slope of 3 to 1, so rise 3, run 1. You only have to plot 2 key points there. Ta-da! Just like all lines, its domain is -infinity to infinity, and its range is -infinity to infinity. Or, if you like your set builder notation, all values of x such that x is an element of the real. Or if you like your set builder notation, all values of y such that y is an element of the real. Next up is the inequality, and I'm going to strike out its domain and range. Let's say you might convert it to mx plus b, and you probably should. So that gets over there, -6y greater than -4x plus 24. Divide that negative symbol out. Revert back to 8th grade. When you divide by a negative, the inequality symbol flips. If you don't know why that's true, you feel free to ask me because I actually know. So y is less than 2/3 of x minus 4. And then go to town on it. Let's see, we do not have equality, so at -4 there's an open hole. The slope is to rise 2 and run 3. Looks like it'd be about right there, or conversely fall 2 and run 3 to the left. She is dashed. That is a less than symbol, which means below or left. In this case, it's below. Ta-da! Ooh, we have an absolute value function. We've got a right 3. We have a up 5. And this is my kind of slope. So right 3, rise 5. Puts me about right there. Then fall 2, run 1 both ways. There we go. There's my v. Domain of all v's is -infinity to infinity. Or if I like my set builder notation, all values of x, sorry, I'm tired, such that x is an element of the real. The range here, the low value is -infinity, and it rises all the way to 5. Look at that 5 up there. Rises all the way to 5 with a bracket, because that's a solid dot. Or all values of y such that y is less than or equal to 5. Almost done. And I need to be. About to have some kids at my door. Twice x minus 1 squared plus 3. So we have a right 1, and we have an up 3. This is my kind of slope. So right 1 up 3 puts me right here, and I am to rise 2 and run 1. And I am drawing the parabola, not a v. It is a parabola because of the square, and its domain is -infinity to infinity, or all values of x such that x is an element of the real. Its range is 3 up, so 3 to infinity, or all values of y such that y is greater than or equal to 3. We're almost done with this little video. Sorry you couldn't see that. There you go. Now you can pause it. Number 10, we get the piecewise function. Graph this thing. We are 3 if x is stuck between -6 and 1. I graded your last test like nobody made tables. I mean, there's 2 points on the graph. I've got -6, 3, and then 1, 3. So -6, 3. Then I have 1, 3. And 1, 3's got to be open hold because of that. There's those 2 points. I've got this guy right here. Input of x, output of 2x plus 2. If I throw a 1 at 2x plus 2, I get back a 4. If I throw a 3, I get back a 6. This one does not have equality, so it'll be open hold. But 1, 4 is on the grid. as is 3, 6. And then lastly, I have this thing. Input of x, output of negative x. I can feed it 3, 4, 5, dot, 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 forever. And it's just going to return the negatives of those things. So 3, negative 3 is a point, and it is solid because I'm looking at my symbolism. And then it seems to go down 1 for all of time, like that. And that's the piecewise function. Here's 11. 11 will actually be a bonus. Below is a table of values describing f of x. Create a table for negative f of 2x plus 3. You're supposed to reflect, stretch, and shift. So I'm going to do this first. Just a 3-part process. If you don't like stuff like this, well, next year you know what math to take. You don't take anything where you see Milbrath. So negative f of x is only going to change the signs on y because f of x is fancy for y. So this becomes negative 5, negative 9, and then positive 3. Then there's this guy, f of 2x. What does that 2 do? That 2 cuts x values in half. It has no effect on output, only input. This will be negative f of 2x now. And the output stays the same, negative 5, negative 9, 3, but the input becomes 4, 6, 7. Then we have the plus 3, which is the last thing. It adds 3 to output. Does not affect input, just affects output. So the input is now 4, 6, 7, and the output gets 3 added to it. Negative 5 plus 3 is negative 2, negative 9 plus 3 is negative 6, and 3 plus 3 is 6. And that's how you do something like that. But not hard. Math is only as hard as you let it be. That's a fact. And if you give it no respect, it won't give you any back.